This is the homework for 138, 140, 141, and 142A. For 138, you need to determine the corresponding outputs for the given inputs. So when we input A into f of x equals the absolute value of x, so x equals 8, absolute value of 8 is 8. And remember, the absolute value is the distance from 0. So if x of equaled negative 8, absolute value of negative 8 would also be 8 because the distance from 0 to negative 8 is 8 units. B, x equals 2. So f of x equals 3 to the x power. Well, x equals 2, so it's 3 squared plus 1. So f of 2 equals 3 squared plus 1. 3 squared means 3 multiplied by 3, not 3 times 2. 3 multiplied by 3 equals 9. 9 plus 1 is 10. So f of 2 equals 10. For C, k equals negative 6. So we have the function of k equals k over 2 plus 1. So substitute k with negative 6. So the function of negative 6 equals negative 2 divided by 2. Negative divided by a positive is going to be a negative. So negative 6 divided by 2 equals negative 3. Now we have negative 3 plus 1. We have more negatives than a positive, so we know the value is going to be a negative number. Signs are opposite, so we subtract. 3 minus 1 is 2. So we get the function of negative 6 equals negative 2. We have x equals 3, and we have f of x equals the square root of x minus 5. So we're going to substitute x with the value of 3, and now we have 3 minus 5. Well, we know we have more negatives than positives, so we know the value is going to be a negative number. 3 minus 5 is negative 2. Now we have f of 3 equals the square root of negative 2. Well, here we have a negative number under the radical, and there's not a number when we factor this that we can multiply it by itself and get negative 2. Because anytime you multiply, if we were to multiply 2 negatives, you're going to get a positive. And if we're going to multiply 2 positives, we'd get a positive and not a negative. So there's no real solution. For number 40, a line passes through the points negative 3, negative 2, and 2, 1. Does it also pass through 5, 3? So let's review plotting points. So you always start at the origin, and we're going to have point A at negative 3 on the x, negative 2 on the y. There's point A. Point B is at 2 on the x and 1 on the y. And point C is going to be at 5 on the x, 1, 2, 3, 4, 5, and 3 on the y. When we draw a line through points A and B, this line does not pass through point C. So this one, it's possible that you could have your line drawn a little off, and it looks like it's going through point C. So there's a more precise way of doing this. And that is finding the slope between 2 points, or the rate of change. So if the points are all on the same line, they would have the same rate of change, or same slope. And one way of doing it is counting the rate of change just by going rise over run. And So we go 1, 2, 3, rise, 1, 2, 3, 4, 5. So that's 3/5, 3 over 5. Well, 1, 2, 3, 1, 2, 3, 4, 5. Well, it's not on this point. You can see it doesn't go through C. So we could also do it by using the slope formula, the difference of the y's over the difference of the x's, rise over run. And we can take points A and B, difference of the y's, from A and B, from 1 minus a negative 2, and 2 minus a negative 3, and we get the 3/5 like we did here. And then you would do that for points B to C, and you can see that the slope or rate of change from B to C is 2/3. Since these two do not match, they are not on the same line. For 41a, we need to perform the indicated operation to evaluate each expression without using a calculator. So we have 1/2 plus a negative 1/5. So I like to call these digs because you dig down 1/2 or half a foot, and then you dig down 1/5 of a foot. So when you're going a negative and a negative, you're adding those two negatives together. So now we need to find the common denominator, and we do that by finding the least common multiple for 2 and 5, which is 10. And what did we do to the number 2 to get 10? Well, we multiplied it by 5. But what you do to the denominator, you do to the numerator. And here, I'm multiplying it by 1. And the identity property of multiplication doesn't change the value of this. It keeps it the same value. So 1 multiplied by 5 is 5. 2 multiplied by 10 is 10. So we have negative 5/10, which is still equivalent to negative 1/2. And now we're going to multiply negative 1 multiplied by 2 is negative 2. 5 multiplied by 10 is 10. Now, here's where you're adding these two. It's a dig situation. So you're going to add the two negatives together. 5 plus 2 is 7. And you keep the denominator. So it's negative 7/10. For B, we have another dig situation. So we're just going to combine these two. We know they're both negative, so that we know it's going to be a negative value. So we have 2 and negative 2 and 2/3. For C, we have negative 1 and 2/3 multiplied by negative 2. Well, I'm going to first turn this mixed number into an improper fraction. And I'm going to do that by 3 multiplied by 1 is 3, plus 2 is 5. And so we have a negative 5/3. And the reason why it's not 3 multiplied by negative 1 is because we're not including that negative. We're going to apply that negative at the end. We're only multiplying it by the 1. So now we have negative 5/3 multiplied by negative 2. And here I have, I wrote this as a fraction. Negative 2 divided by 1 is still negative 2. And you multiply straight across. Negative 5 multiplied by negative 2 is a positive 10, because a negative multiplied by negative is a positive. 3 multiplied by 1 is 3. It's an improper fraction. So we can simplify it. 10 divided by 3 is 3 1/3. 41D, negative 2 divided by 2/3. In order to, when you divide by fraction, you take the reciprocal of the second term, and so the reciprocal of 2/3 is 3/2, and it becomes multiplication. So now I'm going to go ahead and write negative 2 as a fraction. And so we have negative 2 multiplied by 3 is negative 6. 1 multiplied by 2 is 2. We can simplify this. -6 divided by 2 equals a -3. For 142, I'm going to do a little review before we answer 42a. If you need more review, you can look at the math notes in this lesson. So here I have two parallel lines cut by a transversal line M. I know these are parallel lines because these two double arrows indicates that these are parallel lines. So when I first started learning how to do angle relationships, I wanted to come up with an easier way to remember. And what I did is I drew a circle and I color coded them like a beach ball. So blue, red, and the same angle here, blue, red. And the reason why is because now I can see which angles are congruent. That means that they're the same. If they're the same color, they're the same, they have the same measure. So A is 123, B, and this angle is also 123 degrees. And all of the blue are the same angles. So it's very quick, you can very quickly identify which angles are congruent. And then you add a blue and a red, and they'll be supplementary. They'll add up to 180 degrees. Those are supplementary angles. So any red and blue will add up to 180 degrees. So let's go ahead and go through all the angle relationships. We have alternate interior angles are congruent. Alternate exterior angles are congruent. You can see by the color. Corresponding, I call them corresponding, just to remember, because that angle slides down, or this angle can slide up, corresponding. And supplementary angles add up to 180 degrees. And then we have vertical angles, angles that are opposite. And vertical angles are congruent, they're equal to one another. For A, the measure of angle A, we know it's 123 degrees because they're corresponding, corresponding angles, those angles, and you can see that they're the same color. For angle B, you also know that it's 123 degrees. Same color, but mathematically, the reason is alternate interior angles are congruent. Or if you found A was 123 degrees, you know that vertical angles are congruent. For C, we know that these two angles, this the measure of this red angle and the measure of angle C, add up to 180 degrees, a straight angle. All lines have a measure of 180 degrees. So if we look at that same angle here, angle C plus 123 degrees equals 180. Or we could say 180 degrees minus this red angle, 123 degrees, will give us C, which is 57. So the measure of angle C is 57 degrees.